Welcome back to Maths with Armin. In this new video on grade 12 CAPS Mathematics, we're going to look at the topic statistics, and specifically we're going to look at standard deviation. Now, what we're going to do exactly in this video is the following. First of all, we're just going to have an overview of the measures of central tendency, right? Then we're also going to look at the measures of dispersion. Dispersion means spread, and those are the range and the standard deviation we're going to look at. Then we're going to have some application problems relating to standard deviation, and then as usual with all the videos there's always an exercise worksheet for you to practice these concepts. Okay, so let's start. So first of all, we're going to have an overview of the measures of central tendency. Let's look at that here. Data can be displayed visually using, if we have data, we can, what you did in the past, you can either show it by means of pie charts, or you can show it by means of bar charts, or you can show it by means of line graphs, and there are different types of line graphs. Then we also have the box and whisker plots that we can use. We have ogives, or also known as the frequency distribution curves, and then we also have histograms that we could use. Data sets can also be described differently. It can also be described using numbers, and there are two ways. We can have the measures of center. In other words, everything is around a particular center, and these are the measures of center: the mode, the median, and the mean. And then we have the measures of dispersion, or the measures of spread, right, and how the data spread. And there are three measures there. There's the range that we can have, then there's variance, and then we also have standard deviation. Let's start off with the measures of center, mode, median, and mean. We're going to do each one individually. So let's start with the mode. What is the mode? That's the data value that is most frequently observed. It can also be the data values, doesn't have to be a single number there. For example, let's say we've got 9 individuals and we have the record of their heights, and the heights are given in centimeters. So there we have the heights of the 9 individuals there. Okay, so what do you observe there? We observe that 154 is the height that seems to be the most common, and that is the mode. So the mode here is 154, 154, 154. There's no other height that occurs more, so the mode is 154. You can also have sometimes more than one mode, and it's possible not to have a mode as well. So the mode in this example is 154. Let's go to the next measure of central tendency, namely the median. Now, what is the median? That is the data value that is positioned in the middle of an ordered set. What do we mean by ordered set? That is important here, that the data set need to be arranged either from the smallest to the largest, or from the largest to the smallest. In other words, either increasing or decreasing. Let's just take an example. There we have a data set, and as you can see, it is arranged from the smallest value until the largest value. And it says there it's positioned in the middle. So let's try to find there. How many data points do we have there? We have 9. So we need to find the one right in the middle. If you follow there, that's the middle. Okay, so what's the position of that middle number? If you look at that middle number here, it's in position number 5. Okay, we have 9 points. How could we get 5? 9 plus 1, which is 10, divided by 2, which is 5. Okay, so if you can see there, that point is right in the middle. That's 4 below and 4 above. So our median in this particular example here is 154. Now, if we count the number of data points here, we have an odd number. In other words, we have n equal to, in this case, n equal to 9, right? So if we have an odd number, you'll find that the median is right in the middle. It's one of the data points. But if it's an even number, for example, let's make the 9, just add an additional 1 to it. So they get 10. So let's just add one additional data point at the end, 190. Now, where is the middle now? You've got an even number. So the middle there is it's not 154, it's not one, it's in between 154 and 155, right? So in other words, you've got 5 below and 5 above. So that point there would be right in the middle. So that is 5.5. And how did we get that position? How many data points are there? 10. 10 plus 1, 11. 11 divided by 2. So that's how you can find your position, right? N 10 plus 1 over 2, which in this case is 11. And 11 over 2 is 5,5. So it's right in the middle there. But to work out the actual median, it's in the middle of 154 and 155. So we just work out a simple arithmetic average there, which is 154 plus 155. And we need to, that's correct, divided by 2, which gives you a value of 154,5. Okay. So if we have an odd one, it's one of the data points. If it's an even one, it's not necessary, it's not one of those 2 points, it's the one in the middle there, unless, for example, I had 155 and another 155, because 155 plus 155 will divide by 2 will still give me 155. So clearly distinguish between if you have an even number or an odd number. Now let's look at our third measure of central tendency, and that is the mean. It's also known as the arithmetic mean, or it's also known as the average. How do we get that? It's the sum of all the data values divided by the total number of data values. So let's look at an example first, and here we're going to take ungrouped data. So I've got 9 data points. We're taking the same data points there, and they're not grouped. And this is the formula based on the definition. It's the sum of, that sigma means the sum of all the x values divided by the number of data values. So we have to find the sum. So we have to take 135 plus 140 up to 180 plus 185. If we do that calculation and divide it by 9, we get 158. So the mean in this, for this data set here, is 158. So the mean there is 158. What do we do if we have grouped data, right? What is grouped data? See, there's grouped data. We've got interval from 0 to 10, and the frequency is 1. Then from 10 to 20, but the 10 excluded, frequency is 2. I'm just taking some cosmetic, some easy numbers for us just to understand the concept, right? So we want to find the arithmetic mean of this group data. Now, here we have a different formula. This formula requires that we have to find the, first of all, we have to find this xi, and this xi here is the midpoint, because, I mean, this one is only one. I don't know which number is it between 0 and 10. So what we do is we find the midpoint of the interval there, the midpoint of that interval. And how would we find that? We'll show you. 0 plus 10 divided by 2. And then once we have the midpoint, we then multiply it by the corresponding frequency number. And then after we obtain the sum, we'll divide it by the number of data values there. So let's just create an extra column here. You know, the sum of the frequencies is 10. That will be my 10 that I'm going to use there. The midpoint, how do we get the midpoint? That's right, it's 0 plus 10 divided by 2. Simple arithmetic, right? And then 10 plus 20 divided by 2, and we can carry on. 20 plus 30 divided by 2, 30 plus 40 divided by 2. And if we do that arithmetic there, it's 5, 15, 25, and 35, right? So that's the midpoint. Now, Now we want to find the product. So what's the product there? It is 1 times the 5. So I must find the product. That's 1 times 5, 2 times 15, 3 times 25, 4 times 35. And if you do that little bit of calculation, you can actually do it quite easily without a calculator. And that gives you 5, 30, 75, and 140. But we want to obtain the sum. So I need the sum of the product. So I find the sum of the product. Now once I have that, there's the numerator part. And this n value is my denominator part. So it's 250 divided by 10. That's quite easy. So my arithmetic mean here would be 25. Now, I want you to quickly try this example here. There's your data set 4, 3, 2, and 1 with a corresponding interval there. It's a frequency table. So let's do that. You can pause this video and try it. Okay. So you first of all have to find the midpoints. Then you take the product of the frequency times the midpoint, and then you find the sum. Once you get the sum, you divide it by the number of data values. Right. You can pause the video and we can try it then. Let's look at the solution to that example. We need to find the sum of the frequencies, and 4 plus 3 plus 2 plus 1, quite easy, that's 10. The midpoint of 0 to 20 is 10, and 20 to 40 is 30, and the next one is 50, 70, we can see, add a 20, add a 20, add a 20. Then we find the product, 4 times 10 and 3 times 30, that should be very easy. You should not be using a calculator, that would be embarrassing. We find the sum of the product. That is 130, and 100 is 230, and plus 70 is 300, right? I've just chosen a cosmetic one that's easy to for you to do without using a scientific or any type of calculator. Now you find that sum there is 300, and now it's just the sum divided by 10. 300 divided by 10, that is equal to 30. So the mean here is 30. Now we're going to look at our next measure, and this is the measure of dispersion or the measure of spread. And this is the different measures we're going to look at: range, variance, and standard deviation. So let's start with the first one, range. Okay, what is the range? Range, there's the difference between the maximum and the minimum values of the data set. So I want the range, it's the maximum subtracted from it the minimum value, right? Or we subtract the minimum from the maximum. Let's take the same data set that we had earlier. So we need to identify the maximum. There's the maximum, and we need to identify the minimum, 135. And then what do we have to do? Just subtract them. So I take the 185. There's the 185, and I just subtract 135 from it. That's quite easy. You don't need a calculator, and that gives you the value 50. So it's just the maximum minus the minimum. Now we're going to show you how to calculate standard deviation. You're going to use it, calculate it using a formula. Let's just get the definition of standard deviation. It's the measure to determine how close or how spread out the values in a data set are to the mean, right? So you've got a lot of data values, and you want to see how close those values are relative to the mean. And this is the formula we're going to use. And xi means the different data values, and this x bar means the mean, and then n is the number of data points, right? So we have to find the difference, then we have to square it, then we have to find the sum, and we have to divide it by n, and we find the square root of that, and that's what's going to be my standard deviation. We're going to first of all look at the calculating the standard deviation using the formula. Okay, so there we have the formula. Let's just see what is required in this formula. We are given a data set, so there's our data set, and these are my xi values. That's xi means that's the x1, the x2, the x3, the x4, and the x5. So there are 5 data values there, so the n will be 5. That there is the mean. So we have to calculate the mean. This mean should be quite easy. How do you find the mean sum? That's 3 plus 4 is 7, 7 plus 5 is 12, 12 plus 8 is 20, 20 divided by 5 is 4. So we should be able to calculate the mean quite easily, right? You can see that we need the mean, so we quickly calculate the mean, and the mean is 4. Okay, now once we have the mean, we have to find the difference. So I have to take 1 minus the mean. So it's 1 subtract 4. So that's going to be 1 subtract the 4. That gives me 1 subtract 4. Then the next one is 2 subtract 4. 4 subtract 4. 5 subtract the mean. 8 subtract the mean. And if we do those calculations, there we get -3, -2, 0, 1, and 4. Okay. Now, because of the negatives there, we're going to square the values, so we don't work with the negatives. So we square, that gives me 3 squared, 2 squared, 0 squared, 1 squared, and 4 squared. So after we found the squares, we need to find, that stands for the sum. So that's quite easy. 9 and 4 is 13, 14, and that gives me a total of 30. Okay, now we're ready to substitute. So I have a square root. So the sum, the numerator part is 30, and the denominator part is the number of data values 5. So it's 30 divided by 5, and square root of that, if we calculate it rounding off to 2 decimal places, would be 2,45. So the standard deviation here is approximately 2,45. Now here's one example for you to try quickly. And again, I've used some cosmetic numbers, 5, 8, 2, and 15. You can do a lot of the calculations here without using a calculator. So first of all, we'll have to find the mean. So I pause and try to do that question on your own. Okay. Let's look at the solution here. First of all, we can see there are 1, 2, 3, 4 data points, so n is equal to 4. And we first have to calculate the mean, and the mean is 7. That's actually quite easy. 5 plus 9 is 14, and that's 16, that's 28. 25, 8 divided by 4 is 7. Then we have to find the differences. There's the differences. Then we square the differences, and we find the sum, which is 58. Therefore, the standard deviation is square root of 58 divided by 4, which gives me 3,8. So the standard deviation there is 3,8. Now we're going to try calculating the standard deviation using your calculator, and we're going to use the stat mode, right? So we're going to take the same example, we're going to calculate the standard, but here we're not going to use the formula. So we're going to use the stat mode on your calculator. I'm taking the same, and then we'll compare the answers there. Now I'm going to show you how you can calculate the standard deviation using your calculator and using the stat mode, right? So there's we're going to use the same data set. Your calculator is switched on, you press the mode setup key, and then this is what will appear on your screen. We want to do the mode stat, so we enter the 2. Once you enter 2, this is what appears on your screen. We want to determine standard deviation, so there's variance, so we choose 1, and then you get a screen like this. Now we just have to enter the values. So it's 1 equal, 2 equal, 3 equal, 5 equal, 8 equal, right? And if you do that, all the data points will be entered, and you'll see you've entered. If you scroll down, you'll be able to see you've entered all 5 there. Okay. Now to save the data set in your calculator, you have to press the AC. Now your data is saved. Don't worry, you'll see a blank screen. Now you have to access the stats again. So you press shift and then with stat, right? And then this screen will pop up. We want to determine variance, and which number is variance in this calculator? It's number 5. It will vary from the model of your calculator. Some of them will show a 4. So if you enter 5, you'll have this screen popping up there, and this will now give you the different measures. That's the number of data values, that is the mean, this is the population standard deviation. We're not going to work with the S stands for the sample standard deviation. But so we have to enter 3. If you enter 3, this will appear on your screen, and then there's the standard deviation. We want to round that off. You see there's your standard deviation. and we want to round it off to 2 decimal places, so it becomes 2,45. You can see it's exactly the same answer we had when we used the formula there, right? So it's preferable for you to use the stat mode. You can save a lot more time this way. But if you don't have a scientific calculator, you can always use the formula. Now, there is two examples for you to try. You can pause and try and calculate the standard deviation there. I've used cosmetic numbers with no decimals just for you to practice the using the stat mode for determining standard deviation. Pause and let's see whether you got the answers right. 2 minutes for each should be more than enough time. So let's look at the solution. So the standard deviation for the first example, if you worked it out correctly, it's 2,24. And if you work out the standard deviation for the second data set, it's 18,27. Okay. Now, standard deviation, how close the data set values are to the mean, right? So the measure that you get will tell you how close the data set values are to the mean. Now you will get two options. You can get a low standard deviation value, and what does that mean is that if you look at the mean, you'll see that your values are very close to the mean. When you have a low standard deviation, your data set values are very close. You see those individuals there, they pack very close to each other, right? And it normally can be represented like that. Okay, so if it's a low standard, all the data values will be very close to the mean. If you have a high standard deviation value, then you'll see that the data values, there's the mean, and now the data values, can you see they're all spread out, they're not all together, right? A little bit of social distancing there. And then if you have to represent that, that will be the graphical representation of that data set, right? So low means they're very close to the mean, high means they spread out more. Now we have another measure, and this is the measure very similar to the previous formula. We've just removed the square root, and then we put the square, then we refer to that measure as variance. That is the word variance that is mentioned on your calculator. Variance is just without the square root, right? Because you remove the square root, you get the sigma squared, the lowercase sigma squared. Okay, and that also is a measure to determine how close the values in the data set are to the mean, right? But we're not going to work with the square values. We're going to work with the square root there when we work with standard deviation. So it's exactly the same. Xi is your data values, that X bar there is your mean, and N is the number of data points. Okay. Now, next we're going to do the applications of these concepts, and specifically standard deviation. So let's look at the first example. Here we have the mathematics marks of a class of 10 boys and 10 girls. And first of all, we want to calculate the mean mark. That's quite easy. You get the mean for the boys. That's the mean for the boys. Calculate the mean for the girls. That should be very easy. Next, we want to work out, and it says we must comment. We notice the means are identical. No difference between them, right? Now we want to calculate the standard deviation. And we notice from the standard deviation here that we calculate the standard deviation using your calculator, not using the formula. We calculate the standard deviation for the girls. Now there's a question there. We have to comment on the spread of the marks of the girls. Now we see they had the same mean, but their standard deviation is different. So the girls there, you can see, is lower than the boys. So the girls has a lower standard deviation. What does it mean if it's lower? It means that their marks, the marks of the girls, are much closer to the mean, where the marks for the boys are much more spread out, you know, it disperses more. Let's look at the next question. For example 1, calculate how many of the boys and girls have a percentage mark that is 1 standard deviation below the mean. You see, 1 standard deviation and you want it below the mean. So 1 standard below the mean, what does that mean? That's correct, it's the mean minus the standard deviation. Right? So what is our mean? We worked it out previously, 71.4%, and the standard deviation for the boys was 18.2%. If we do that subtraction, we get 53.2%. Let's do the same for the girls. Again there, below it's the standard deviation subtracted from the mean. So there's the mean minus the girls' standard deviation, and we get that as 58.5%. Okay, but the question says how many of the boys. So let's look at our table that we have there. So if we look at the boys, how many of the boys have a percentage less? Below means less than. So let's see, less than 53. So we can see it is going to be, that's correct, it's 52. And another one, that's correct, it's 42. And another one, 48. So how many of them are there? That's correct, there are 3 boys, right? And the girls, we want less than 58.5%, which is the first number less than 58.5%, 48, and the other one, 57. So there are 2 girls who have a percentage mark, which is 1 standard deviation below the mean. Let's look at our second example. Here we have the body mass of 20 athletes. There's the 20 athletes, their body mass. Calculate the mean. Should be very simple. The mean is 71.4. And calculate the standard deviation of the body. So the standard deviation using your calculator, that is 15.75. Now we're going to have a question where we have to interpret these 2 values. Now let's look at the third question here of example number 2. There we have our data again, just for easy reference. And this is the new information. It was discovered that the scale that was used was not calibrated correctly, and the error was 5 kilograms for each athlete. You know, normally they set the scale at exactly at 0. Maybe the scale there was not set at 0, it was set below 0. So there's an error of 5. So 5 kilograms. So it was, they underweighed them. So 5 kilograms to each one. For example, instead of 52, that need to be 57, instead of 65, 70, etc. Okay. Now they have some questions here. Calculate the correct mean. How this 5 kilogram, would the 5 kilogram affect the mean or won't it affect the mean? Okay, let's see. If you actually add up those new values and divide them by 20, you'll get the answer. Let's see, we'll get the answer 76.4. But what do we notice? The original mean was 71.4. You just add 5 to it, right? So if 5 kilogram is added to each athlete, you just add 5 kilogram to your mean. You don't have to recalculate everything there. Okay, so it definitely affects the mean. The mean will then increase by 5 kilogram. Then the next question here, the standard deviation. If you should recalculate the standard deviation, you'll notice you get exactly the same answer, right? So if 5 kilogram is added to each value, it doesn't affect the standard deviation, because you're adding 5 to each one, won't make any difference there. So the standard deviation will be unchanged. Now let's look at the exercise worksheet. I've actually taken examples from previous external DBE question papers. Let's look at the first question here. This is a question adapted from the November 2014 paper. Just adapted it somewhat. There we've got the percentages of grade 12 learners. And you have to calculate the mean. Then you have to calculate the standard deviation. And then there's a question about 1 standard deviation from the mean. Read the question carefully. This second question here has been adapted from the February 2015 paper. You have 21 data values there, refers to the distance, and you have to calculate the mean distance, then you have to calculate the standard deviation, and here's one application of the standard deviation. Here we have details of 23 girls. Again, calculate the mean, calculate the standard deviation, and then there's an interpretation there. Okay, this is always the type of question that you will encounter. Here's one more question. It's adapted from the June 2019 paper. Here we have data of 21 learners, and again there calculate the mean, calculate the standard deviation, and here's the interpretation of the mean with 2 questions there. I hope you found this video useful and you have a better understanding of standard deviation. I have developed a number of videos on grade 12 CAPS mathematics, and as you can see at the end of each video there's an exercise worksheet, and I've uploaded the solutions to all the exercise worksheets of all the videos. Please subscribe to my channel, and if you like, just indicate like. Thank you. Until our next video. Thank you.